the frame forwarding process is critical. What is the frame forwarding process all about? It's all about taking frames and forwarding them to their appropriate destinations. So who does the frame forwarding process? It's our switches. In this example, it's going to be ASW1 and DSW1. So if I send a ping right now to 10.1.1.20, how did this work? Right, if you look at PC1, PC1 is connected to Fast Ethernet 0/1 on ASW1. PC2 is connected to Fast Ethernet 0/2 on ASW1. So how did the frame forwarding process work? Well, PC1 sent the frame. The frame was sourced from its local MAC address, ending in 06D6. What was the destination of the frame? The destination of the frame was CE47. Now, how did PC1 know the destination MAC address of CE47? It would have ARPed. That's right, it would have ARPed. It would have used address resolution protocol in order to figure out the MAC address of the IP address of PC2. So we know the IP address is 10.1.1.20. That's what we typed in here. So PC1 says, all right, so 10.1.1.20, that's in my local area network. I have to talk to that device directly. So I'm going to source the frame from myself, 06D6, and send the frame to PC2 directly at CE47. Now, how would it know about this? Well, it would look in its ARP cache. In its ARP cache, it says, if you want to reach 10.1.1.20, use this MAC address. But as I said, if it doesn't know this information in its ARP cache, it would then have to ARP, meaning send out an ARP request saying, hey, if you have the MAC address of 10.1.1.20, hook me up with it, please. And as a result, PC2 would respond back, and then we'd have the information here we need. So we have our frame created, and we go ahead and we send that frame out on our network. So now when we go over to ASW1, let's look at our MAC address table. So show MAC address table dynamic. Let's look here for an entry of 06D6. I see 06D6 right here. That's the MAC address of PC1. Notice that entry is explicitly associated with Fast Ethernet 0/1. Why? Because the frame came from PC1 and arrived inbound on this interface, Fast Ethernet 0/1. When the frame arrived inbound on the interface, the switch said, where did this frame come from? It came from 0800271406D6 on Fast Ethernet 0/1. Therefore, that MAC address must live out that interface because the frame was sourced from a device out that interface. So the switch puts in its MAC address table this entry right here, associating it with Fast Ethernet 0/1. So that's how the switch learns. And we want the switch to learn every single MAC address that is out there in the local area network. That way there, it can perform efficient forwarding of frames. Because if the destination of a frame is not in the MAC address table, what happens to the frame? Yeah, it's going to be flooded out all ports except the port it came in on, which means it's no better than a hub at that point in time, our switch. So we want to make sure that we forward frames efficiently. We only flood when it's absolutely necessary, like with broadcasts. We don't want to have to flood a whole lot of unknown unicast frames. We want to forward unicast frames. So what is the destination MAC address in this case? The destination MAC address in the frame that was received on that interface of Fast Ethernet 0/1 from 06D6, well, the destination is CE47. So our switch does a MAC address table lookup and says, all right, where is 08002714 CE47? According to this, it's out Fast Ethernet 0/2. So if this entry wasn't in our MAC address table, then the switch would have to flood the frame out all ports except the port it came in on. But since we have this entry in our MAC address table, the switch will simply just take the frame and forward it out Fast Ethernet 0/2 down to PC2. So that's the frame forwarding process. But let's look at a more complicated example. Well, it's not really complicated because if you understand the frame forwarding process, it's the same process that just repeats over and over and over again. So this time, let's analyze it from the perspective of pinging our default gateway. So if I ping my default gateway in this case, we have our successful reply. Now, what is the source MAC address of the frame? And what is the destination MAC address of the frame? Well, let's look at our ARP cache here, because we would have had to figure that out. And we can see in our ARP cache, we can reach 10.1.1 using B8 3861 AD 7340.